Today we're going to look at developing terms that will help you throughout the semester. And basically we're going to be putting it all together. So you have your YouTube video link, and here's your presentation that will last today for about 20 minutes. So I want to talk a little bit about the ways in which scholarship in motor learning occurs, or another way of me describing this is the forms of scholarship in motor behavior. There's theoretical knowledge, empirical knowledge, basic knowledge, and applied knowledge, and you can see how these various ideas fit on different continua. So if I define for you what theory is, it is developed based upon a set of very broad principles and concepts. And what scholars do is they use the process of deduction in order to be able to make predictions. Generally, we call those predictions hypotheses. Empirical research or empiricism is induction. Induction means observation of phenomena. So an example of this would be when we go into the laboratory and we do research on motor learning. That would be considered empirical research. Basic research is conducted to explain underlying phenomena, sometimes things that we really can't see in the real world, and for that reason it seems esoteric, or it's very difficult to make application of this knowledge. But know that basic knowledge is very important in research and to the discovery of new knowledge. Applied research is conducted in settings that have real-world values. So I might actually do a study where I have participants videotaped while they're doing performance of a deadlift, and then I compare their performance on the videotape to the performance of, let's say, the most perfect deadlift. So to what extent does being able to match your movement to a model's movement affect the learning of that movement? You can see how that would be applied research because it's conducted in the gymnasium, in the weight room. Neither basic nor applied is better than the other. I believe that both are necessary. So what I'd like for you to do is take a couple of minutes and articulate to yourselves in one or two sentences where you see Rothstein, Gentile, and Schmidt fitting on this continuum that I have here. Notice basic research is on one side, applied research is on the other side. Where would you put Rothstein, Gentile, and Schmidt in relation to each other? And by the way, there is no correct answer here. So what I want you to realize is that theory, which is based upon the development of knowledge that exists in the literature, and we call that literature the scholarly literature, we use that literature to integrate and make predictions about how things will happen. Now, although we attempt to omit as much as possible bias that we have, it's very difficult at every level to eliminate bias. And so wherever possible, we want to look for this. And we also have to circumspect our hypotheses to understand better whether we have that bias or whether we really are objective in our reasoning. Empirical researchers also need to scrutinize the findings or the results that people get in their empirical research and actually conduct that research across multiple settings, and also to be able to repeat the research numerous times exactly the same way, even within the same setting. And we do that in order to really be able to know whether a theoretical idea or a hypothesis is correct or incorrect. And then the theory actually over time, many years generally, can either be supported or refuted. So here I've given you an example of competing theories. For example, the theory of evolution or the theory of intelligent design. And I don't mean to make a political statement here, but neither of these is correct. Both are theoretical. You might believe one is more correct than the other, but that doesn't make that one the correct theory. Until we develop proof of the hypotheses in these theories, then we can say that we support one theory over the other. So where do my research interests lie in motor learning with regard to this continuum? I've been involved in experimental research in the Applied Motor Behavior Lab for the last 25 years or so. And what we do in experimental research is we define a set of variables, we create a way of measuring those variables, and then we develop an experiment where we manipulate those variables and we also control for the environment and as many factors in that environment as we possibly can. By doing this, we're better able to attribute our findings to the manipulations that we did with our variables. I'm going to be defining more of these terms in lab next week, and so will Danica in her labs. I think my work also, like Ann Rothstein, is a place where I've bridged the gap. My experience at the University of Georgia and the University of Colorado, working in the labs there, really placed my work at the center of that continuum. And the reason is that John Shea's research was truly more basic in nature in terms of motor learning theory or in terms of motor learning empiricism. And Pat Del Rey at the University of Georgia was really a more applied researcher, and that, to a certain extent, was based upon who their major professors were. Specifically, my interests in motor learning have been on memory and expertise, and contextual interference and elaboration strategies. We're going to talk about each of these different ideas over the course of the semester, so I look forward to getting into our discussion about these ideas. What is psychology? Psychology really is the study of human and animal behavior. And if I asked you the question, what is motor learning? The answer would be that motor learning is the study of how humans, animals, and notice today I've added the word machines, or the idea about machines, how they learn and perform motor skills. I could write exactly this statement here as motor learning is the study of human and animal behavior. Notice that the definition of psychology is used again in the definition of motor learning. Because in fact, when I look at how the field of psychology is organized, look at all these various ways or applications of psychology. In other words, a psychologist could look at what's called developmental psychology. I know that most of you have heard that terminology. There is also something called an industrial organizational psychologist, somebody who goes into industry and looks at systems and how those systems work and how you could benefit employees and the efficiency of work output. As well, notice there's an area called psychometrics. This is measurement and evaluation in psychology, metrics that look at psychology or measures that look at psychology. Clinical psychology, if you've ever been to a therapist, they're a person that has studied clinical psychology. And the area of experimental psychology, which in the last 50 years has truly grown into many specific areas. For example, the area of cognitive psychology or perceptual psychology, and so on. Notice how motor learning is included here. In fact, experimental psychologists actually studied motor learning in the 1950s. So although it took till the 1960s for motor learning to come to physical education at the time, it really existed in psychology in the 1950s and probably previous to that because of the conflict in the world and the need to develop troopers, etc. Notice physiological psychology, very similar to what we have in our field of kinesiology. And what I want you to think about now is, have you taken a psychology course? And if you've taken a psychology course, was it a specific course on one of these issues or applications? Or was it a course in general psychology where you actually looked at all of these areas and it was to introduce you to these areas so that if you wanted to study more deeply, you would know what area to pick? Notice how I've included human factors in this slide, because human factors actually, although at San Jose State is found in the College of Engineering, it also is found in the Department of Psychology at San Jose State University. So here you see the way that kinesiology is organized. And I've already mentioned to you in other contexts subdisciplinary perspectives. In other words, taking very narrow approaches and using those approaches to talk about movement and physical activity. So notice sport and exercise psychology, motor development, motor behavior, adapted physical activity, and on and on and on. What I want you to see is the similarity in the courses that are offered here in kinesiology, or the applications that we have in kinesiology, to the applications that they have in psychology. So think about it. Can you provide an example of research in any one of these areas? Can you see how the field of psychology is related to the field of motor learning specifically, but how the fields are somewhat structured or organized in similar ways? So what is motor behavior? Motor behavior is a larger area than motor learning. I would say that motor learning is part of motor behavior. As a matter of fact, there's an organization called the North American Society for the Psychology of Sport and Physical Activity. And it defines motor behavior as motor learning, motor control, sports psychology, and motor development. Probably today in NASPA, they would also talk about dynamic systems. Motor learning specifically is looking at the cognitive processing that underlies motor skill behavior. Motor control is looking at the motor programming and the organization of the movement. In other words, how do you reach out and grasp something? How do you take this paperweight and pick it up from the table with fluidity? In a dynamic systems approach, we take a complex systems approach to try to explain behavior. And this can also include a psychological, physiological, or mechanical perspective, or the constraints of physiological, mechanical, and also psychological. Sports psychology is an interesting area. It's the study of the psychological effects on performance of motor skills. You could look at team dynamics, motivational strategies, one-on-one kind of clinical counseling in sport. The area of sports psychology really grew out of early motor learning. It was the early motor learners who actually looked at the area of sports psychology and developed the early research that was published in this area. And motor development, we've discussed to a certain degree, is looking across the lifespan. And if you're interested in doing that across many different disciplines, motor development is a great area of study that takes an interdisciplinary approach. So for the rest of our class, from here through the end of May, what I want you to start to do is think about skill as separate entities. What I mean by that is not to think about the sport of basketball when we talk about examples, but rather what I would like for you to do is tell me about what skill in basketball you're talking about. Are you talking about the basketball free throw? Are you talking about a basketball pass? Does that free throw come in a game situation like a championship game or the first game of the season? Does it come in an empty gym just during practice? Does the pass come as just a practice drill between me and my partner? Or is it against a teammate in a very important game? All of that is very important to our discussion as we begin to define different aspects of motor skill performance. Look at the two pictures that I have here on the slides. You can see that in the left slide here is my keyboard for the regular desktop, and here's my keypad for the iPad. I have to hold my hands, the motor control that I have to have for each of those keypads is different with regard to the parameters that I would attach and how big or the distance between my digits is going to be. So what I want us to do is think about goal-directed movement. And what goal-directed movement is that it's movement carried out to meet a particular goal. It's voluntary and the performer controls it directly. So here are some examples. The tennis serve on the brand new SJSU tennis courts. A volleyball set in an empty gym. Typing an email on my desktop. Speaking to a friend on a cell phone. Driving a Maserati. Now, I don't know if I really want to drive a Maserati, but I would like to have the money to drive a Maserati. Eating a steak or picking up a cup of coffee. And we know that coffee cups come in many shapes and many weights, so that affects the motor control or the parameters that I would attach to pick up different cups of coffee. It changes the context. Soon we're going to talk about and take a closer look at skill and human performance. But before we begin to do that, I want to just take 1 minute to present to you an overly simplified information processing model. You could see here that there are 3 stages in this model, very simple. You have input as a stage. You have what I'm calling here central processing, and then you have output. Notice that central processing includes perception, decision, and effector. Over the next 14 weeks or so, we're going to unpack perception, decision, and effector and understand memory and performance as a result of changes or manipulations that might occur with regard to these three stages of the central processing unit. So just as a reminder for next week, Tuesday, February 6th, class is regularly scheduled online. You'll find a PowerPoint on Canvas with a YouTube link as usual at 9 a.m. Make sure to preview the PowerPoint before returning to class on Thursday when we're going to meet in BBC 202. I'm looking forward to seeing you all again in person, and I hope that this works for you. Take your time in viewing the slides and also the video. Have a great weekend, everybody.